Jai Hind. Today we start next section of three-dimensional geometry, section formula. Actually, what is section formula? That means a line that passes through two fixed points. First point is a x1, y1, z1, and second point b x2, y2, z2. Suppose we want to find a particular point P, that is P. The required point is represented by the coordinate is x, y, z, which divides A and B in the ratio m is to n. M is to n. Then the coordinate of P is determined by using the formula P x, y, z is equal to m x2 plus n x1 divided by m plus n, comma m y2 plus n y1 by m plus n, and m z2 plus n z1 divided by m plus n. Using this formula, we find the coordinate of P. This is called the section formula for internal division. Actually, P lies between A and B. That means P x, y, z is lie inside A and B. So, it is called the section formula for internal division. Okay, section formula for internal division. It is a point P x, y, z divides the line segment joining A x1, y1, z1 and B x2, y2, z2 in the ratio m is to n. Therefore, P x, y, z equal to m x2 plus n x1 by m plus n, m y2 plus n y1 by m plus n, and m z2 plus n z1 by m plus n. Now, second is section formula for external division. External division. What is section formula for external division? That is a line. A line passing through two fixed points. Our first point is A x1, y1, z2, and second point is B x2, y2, z2. Our required point lies outside AB. That is, suppose we take a B, P. The required point is represented by the variable coordinate x, y, z. That is, P divides A and B in the ratio m is to n. Then the coordinate of P x, y, z is equal to, using formula, m x2 minus n x1 by m minus n, m y2 minus n y1 by m minus n, and m z2 minus n z1 divided by m minus n is called section formula for external division. That means our required point lies outside AB. Actually, the proof of this portion is not included in the syllabus. So, നമുക്ക് ഈ ഒരു ഇതിൻ്റെ പ്രൂഫ് നമുക്ക് ഓട്ടോമാറ്റിക്കായിട്ട് അവോയ്ഡ് ചെയ്യാം. We want only formula. And last is a line, that line passed through two fixed points are A x1, y1, z1 and second point B x2, y2, z2. P is the midpoint of the line segment joining A x1, y1, z1 and B x2, y2, z2. Therefore, P divides AB in the ratio 1 is to 1, and therefore, the point P x, y, z is called the midpoint formula. P midpoint formula. P x, y, z equal to, here we use the formula x1 plus x2 by 2, y1 plus y2 by 2, and z1 plus z2 divided by 2. This is called midpoint formula. Which is called section formula for internal division. This formula is called section formula for external division, and this point is called formula is called midpoint formula. Actually, midpoint formula is developed using internal division. Section formula for internal division using. Here m and n are equal, and therefore 1 into x2 plus 1 into x1, that is x1 plus x2 divided by 1 plus 2. Using this formula, we get this formula also. x1 plus x2 by 2, y1 plus y2 by 2, and z1 plus z2. That means these are the main three formulas regarding the topic section formula. Now, we will start our problem based on this topic. The first question. Find the coordinate of a point which divides the line segment joining minus 2, 3, 5 and 1, minus 4, 6 in the ratio 2 is to 3. Find the coordinate of a point. Actually, NCERT test 12.3 first question. Find the coordinate of the point which divide the line segment joining -2, 3, 5, and second point is 1, -4, 6. The ratio m is to n is 2:3. First question is internally and the second question is externally. Here -2, 3, 5 is considered as x1, y1, z1, and 1 - 4, 6 is considered as x2, y2, z2. Also m is to n is equal to 2:3. Okay. Now we find for internal division, you know the formula internal division. Internal division, you know p, x, y, z is the required point which divides, here you consider a and b in the ratio 2:3. Therefore, p x y is equal to, you know formula, m x2 plus n x1 divided by m plus n, m y2 plus n y1 by m plus n, and m z2 plus n z1 divided by m plus n. Now we substitute the value of m, n and x1, y1, z1 and x2, y2 we get answer, that is 2 into x2 correspond to 1 plus 3 into x1 correspond to -2 divided by m plus n is 5. Then again 2 into y2 correspond to -4 plus 3 into y1 correspond to 3 divided by 5. And last m is, that is 2 into z2 correspond to 6 plus 3 into z1 correspond to 5 divided by m plus n is 5. That is equal to, we get answer. Now add this term, we get answer 2 minus 6, 2 minus 6. What is 2 minus 6? 2 minus 6 is -4 divided by 5. Minus 8 plus 9 is 1 divided by 5. And 12 plus 15, that is 27 divided by 5, which is the required point. If p x y z is equal to, we get answer -4 by 5, 1 by 5 and 27 divided by 5. For external division, it's a direct problem. For external division, our formula changes to p x y z is equal to, now our formula is m x2 minus n x1 divided by m minus n, m y2 minus n y1 by m minus n, and m z2 minus n z1 divided by m minus n. And therefore we get answer here. M and n correspond to same 2 and 3, x and x2 are, this only change in the plus change to minus, that is 2 minus or minus plus 3 divided by m minus means 2 minus 3 and is -1. Okay, 2 into 2 minus or minus 2 plus minus 3 into -2, that is 2 plus 6, 2 plus 6 divided by -1. Then 2 into -4, that is -8 minus 9 divided by -1. And last 12 minus 15 divided by -1, that is equal to, we get answer -8, then 17 and 3. That is the required point. That's all. It's a direct question. It's not a difficult question. Okay. Now we'll discuss one more question based on section formula. Our next question is, find the ratio in which, that is 12.3, 12.3, question number 2. Find the ratio in which the YZ plane divide the line segment joining the points. So find the ratio in which the YZ plane divides the line segment joining the points A -2, 4, 7, -2, 4, 7. And B 3, -5, 8, 3, -5, 8. Find the ratio in which the YZ plane divide the line segment joining the points A -2, 4, 7 and B 3, -5, 8. That means here the given line, that is AB, crosses YZ plane. You know, here is X, Y, and this is Z. YZ plane means they lies in this plane. You know, a line crosses YZ plane. Suppose this is the crossing point. Given line pass through two fixed points are A and B. since the line crosses YZ plane, you know, in a YZ plane, here the coordinate is Y coordinate and Z coordinate are there, but X coordinate becomes 0, that is Y0 YZ. So any point on the YZ plane is in the form 0 YZ. Suppose the line crosses in the XY plane, then we get S and Y coordinate are given, but Z coordinate become 0 ആയിരിക്കും. അപ്പോൾ in the YZ പ്ലെയിനിൽ നമ്മുടെ ലൈൻ ക്രോസ് ചെയ്യുമ്പോൾ അതിൻ്റെ X കോർഡിനേറ്റ് ബിക്കം 0 ആയിരിക്കും, Y കോർഡിനേറ്റും Z കോർഡിനേറ്റും വാല്യൂ ഉണ്ടാവും. അപ്പോൾ സപ്പോസ് യൂസിങ് സെക്ഷൻ ഫോർമുല ഹിയർ, യൂസിങ് സെക്ഷൻ ഫോർമുല, let Pxyz, so you take Pxyz divides the line segment joining A B in the ratio m is to n. Suppose you take Pxyz divides AB in the ratio m is to n, and therefore Pxyz is equal to, you know, formula m x2 plus n x1 divided by m plus n, m y2 plus n y1 by m plus n, and m z2 plus n z1 divided by m plus n, which is a P. That is, here actually, you know, m is to n is unknown. നമുക്കിവിടെ റേഷ്യോ കണ്ടെത്തേണ്ടത് m is to unknown ആണ്. But x1 y1 z1 is -2 4 7 and x2 y2 z3 3 minus 5 substitute here. Therefore we get answer m into 3 plus n into -2 divided by m plus n. Again m into -5 plus n into 4 divided by m plus n. And m into 8 plus n into 7 divided by m plus n. Actually this Pxyz is lying between A and B. Pxyz P എന്നുള്ള പോയിന്റ് നമുക്ക് ഈ പറഞ്ഞ എക്കും ബിയും ലൈൻ ജോയിൻ ചെയ്യുന്ന ലൈൻ സെഗ്മെൻറ്റിൽ എവിടെ വേണം നമുക്ക് കൺസിഡർ ചെയ്യാം, എയും ബി എന്നുള്ള പോയിൻറ്റ്സ് ആവും എവിടെ ഇത് എവിടെ വേണം കൺസിഡർ ചെയ്യാം. സപ്പോസ് ഈ പി എ നമ്മൾ ക്രോസ് സെക്ഷനിൽ, ഐ മീൻ YZ പ്ലെയിൻ ക്രോസ് ചെയ്യുന്ന പോയിന്റിൽ കൺസിഡർ ചെയ്താൽ, since the line cross YZ plane, YZ plane, because Pxy is a variable point, Pxy is a cross ചെയ്യുന്ന പോയിന്റിൽ കൺസിഡർ ചെയ്ത് കഴിഞ്ഞാൽ ഈ Pxyൻ്റെ X coordinate becomes 0. Since the line crosses YZ plane, therefore X coordinate of P is equal to 0. കാരണം പി എന്ന് പറയുമ്പോൾ എക്കും ബിക്ക് എവിടെ വേണം കൺസിഡർ ചെയ്യാം, ബിക്കോസ് ഇറ്റ്സ് എ വേരിയബിൾ പോയിന്റ്. ബട്ട് ഇൻ ദിസ് പൊസിഷനിലെത്തുമ്പോൾ YZ പ്ലെയിൻ ക്രോസ് ചെയ്യുന്ന പോയിന്റിലെത്തുമ്പോൾ ഈ പിൻ്റെ എക്സ് കോർഡിനേറ്റ് ബിക്കം 0. ദാറ്റ് ഈസ് 3m minus 2n divided by m plus n is equal to 0. m close here, therefore we get answer 3m is equal to 2n. That implies m divided by n, cross here m not m, 3 right to cross here, therefore m by n is equal to, we get answer 2 by 3, and therefore the required ratio m is to n is equal to, we get answer 2 is to 3. That's all. Okay, that means here the P, I mean in the YZ plane, the point A and B dividing the ratio is 2 is to 3. Okay, now discuss one more question based on this topic. Next question is a very important question. Question is prove that A 2 minus 3 4, B minus 1 2 1, and C 0 1 by 3 2 are collinear using section formula. Prove that A 2 minus 3 4, B minus 1 2 1, and C 0 1 by 3 2 are collinear using section formula. Already you know how to prove collinearity using distance formula. That means we find A, B, B, C and AC, and large side is equal to sum of other two sides, and therefore we get A, B, C are collinear. That's actually proved in our last video. You already know distance formula വെച്ച് നമ്മളെങ്ങനെ collinearity prove ചെയ്യുന്നത് നമ്മൾ already discuss ചെയ്തിട്ടുണ്ട്. Now here we have to prove that these 3 points are collinear using section formula. Section formula use ചെയ്ത് ഈ 3 points are collinear എന്ന് prove ചെയ്യുക. That means Here we prove that A, B, C lie in a same line of action. That means here we have to prove that A, B, C are lie in a same line of action using section formula. Okay. First is using section formula. Suppose you consider P. Suppose P X, Y, Z divides. Suppose we take P X, Y, Z divides A, B in the ratio M is to N. Suppose you consider the point P. P is any variable point. Suppose you take a P X, Y, Z divides A and B in the ratio M is to N. And therefore, using section formula, you know formula P X, Y, Z is equal to M into x2. Here x2 correspond to minus 1 plus n into x1 correspond to 2 divided by m plus n. M into y2 plus n into y1 divided by m plus n. And m into z2 plus n into z1 divided by m plus n is actually Px, Y, Z. Now, we coincide this point P with C. Now, we coincide this point P with C. Here we have to prove that these points are collinear using section formula. So, first of all, we consider a point P X, Y, Z another point consider. Suppose you take a P X, Y, Z is any point. We should divide these two points in the ratio M is to N. And therefore, section formula applying, we get answer P X, Y, Z is this. Now, we coincide with it. Now, we coincide P X, Y, Z with C 0, 1 by 3, 2. That means the x coordinate of P is equal to 0, y coordinate of P is equal to 1 by 3 and z coordinate of P is equal to 2. Now, we equating the corresponding coordinate. That means P is equal to CR. So, we will equate here. Our next step, that is minus m plus 2n divided by m plus n is equal to 0. Therefore, minus m plus 2n is equal to 0. And therefore, minus m is equal to minus 2n. And minus cancel. M by n is equal to, we get answer 2 by 1. That is m is to n is equal to, we get answer 2 is to 1. First, we equate the x coordinate of P with 0. Second, we equate the y coordinate of P with 1 by 3. That is 2m minus 3n divided by m plus n is equal to the y coordinate of C is 1 by 3. Now, cross multiplying, we get answer 3 into 2m minus 3n is equal to m plus n into 1. That is 6m minus 9n is equal to m plus n. It is 6m minus m is equal to n plus 9n. 9 minus 9 right side onto. And therefore, 5m is equal to 10n. That implies m divided by n is equal to 10 by 5. We get answer 2 by 1. That is m is to n is equal to, we get answer 2 is to 1. And last, the coordinate of z coordinate, that is m into 1 plus 4 into n divided by m plus n is equal to the z coordinate of C, because P is coincided with C and therefore z coordinate is also equal to 2. That implies m plus 4n is equal to 2m plus 2n. Here I am going to cross see that, but 2 into m plus 2 into n. It is m minus 2m is equal to 2n minus 4n. That is minus m is equal to minus 2n. And therefore, m is equal to n, m by n is equal to 2 by 1. That implies m is to n is equal to 2 is to 1. Now, coincide actually C ennulla point A and B ennulla point 2 is to 1 divide ചെയ്തു പോകുന്നു. That is, in a line segment A and B, here C divides C എന്നുള്ള പോയിന്റ് എയിലേക്കുള്ള ഡിസ്റ്റൻസ് 2ഉം ബിയിലേക്കുള്ള ഡിസ്റ്റൻസ് 1 ആണ്. Therefore, P is actually equal to C and therefore we get C 0 1 by 3 2 divides C is equal to Pxyz. നമുക്ക് റേഷ്യോ സെയിം ആയി കിട്ടുകയുണ്ട്. പിന്നെ നമുക്ക് ക്ലിയർ ആയിട്ട് എഴുതാം. Therefore C divides AB internally in the ratio AB in the ratio 2:1. That means actually C lies between A and B, and therefore A, B, C are collinear, and therefore A, B, C are collinear because C lies between A and B. That means A, B, C lie in the same line of action, and therefore A, B, C are collinear. Okay, that's all. Here first you take using section formula. First of all you take Pxyz is any point which divides first given 2 points which divides AB in the ratio m:n. Then in section formula we get in terms of m and n. Now this P is coincide with the third point C. ഇപ്പോൾ Pxyzൻ്റെ C ആയിട്ട് നമ്മൾ കോയിൻസൈഡ് ചെയ്യുമ്പോൾ എക്സ് വൈ ഇസഡ് കോർഡിനേറ്റുകൾ പരസ്പരം ഇക്വേറ്റ് ചെയ്യുമ്പോൾ സെയിം റേഷ്യോ നമുക്ക് കിട്ടണം. സെയിം റേഷ്യോ കിട്ടിയാൽ ക്ലിയർ ആണ്. സി ആണ് ശരിക്കും പി എന്നുള്ള പോയിന്റ്. ആൻഡ് സി എ ആൻഡ് ബി എ ഏത് റേഷ്യോ ഡിവൈഡ് ചെയ്ത് പോകുന്നു? ഹിയർ വി ഗെറ്റ് 2:1 റേഷ്യോ ഡിവൈഡ് ചെയ്ത് പോകുന്നു. ദാറ്റ് മീൻ സി ഈസ് ലൈ ഇൻസൈഡ് എ ബി, ബിറ്റ്വീൻ എ ബി, and therefore clearly we get these 3 points lie in the same line. That means A, B, C are collinear. This is a second method for proving the collinearity of 3 points. Actually in this chapter last video we discussed how to prove collinearity using distance formula. Okay, this is the second method, that is section formula use ചെയ്ത് നമ്മൾ എന്ത് ചെയ്യുന്നു, we have to prove the collinearity of 3 points. Okay, that's all today's class. Next class we will discuss centroid of a triangle and the problem based on that topic. Okay, bye.